Hello, in this video I am going to solve question 5 from problem set 1. Let us read the question together first. Let X be a set with more than one element, and let D be a real valued function defined on X Cartesian product X. Show that D is a metric on X, IFF, as a shorthand notation for if and only if, for all A, B, and Z in X. The two conditions that you see here are both satisfied. The first condition is that D of A and B is 0 if and only if A is equal to B, and D of A and B is less than or equal to D of Z and A plus D of Z and B. Okay, because this is an if and only if question, we have to consider two cases. First, we consider that D is a metric on X, and we show that the D satisfies both these conditions. And later, we have to assume that we have a function which is defined on X cross X as a real valued function satisfying these two conditions. We want to show that D is indeed a metric on X. Okay, let us start with the first part. Okay, so here I'm assuming that D is a metric. So I would say let D be a metric on X. Okay? So we know that D satisfies the four axioms of being a metric. So I don't need to do anything with the first part because that is exactly one of the axioms that we impose on any metric, including this metric D. So if D is a metric, the first condition by the definition of a metric is automatically satisfied. For the second part, we have to see that this is not exactly the triangle inequality, because in the triangle inequality we have D of A and B is less than or equal to D A and Z plus D of Z and B. Okay, but here we have D, Z, and A. But that's also not a big problem because D is a metric. We're assuming D is a metric, so it is symmetric. So let us say it like this. So D is a metric. So what can we conclude? We can conclude that D of A and Z is equal to D of Z and A. Okay? And now we know that because D is a metric, D of A and B is less than or equal to D of A and Z plus D of Z and B. Okay? D is a metric, it is symmetric, so I have this equality. D is a metric, so I have the triangle inequality. But now you immediately see that because this is equal to that, in this inequality, I can take this and replace it with D of Z and A. And then I am done. So this implies that DA and B is less than or equal to D Z and A plus D Z and B. Okay, so that's actually the simple part. So if D is a metric, I was able to show that both these conditions are satisfied. Now let us assume that D is a real valued function defined on X Cartesian X satisfying these two conditions. We want to show that D is indeed a metric. Okay, so let me just write this as a summary. So let D be a real valued function defined on X satisfying the given properties. We show that D is is a metric. D is a metric on X. Okay. The first thing that I have to show in order to show that D is a metric, I should show that the output of D is a non-negative number. So what should I say? I would say that for the first part, let alpha and beta be in X. They are arbitrary elements in X. We show that D of alpha and beta is non-negative. Okay, but how can we do that? Because I am assuming that my D satisfies this inequality for all choices of A, B, and Z in X, I can use this inequality and use this particular substitution. So here I would say that let us interchange A with beta, and let me change B, interchange B with beta as well, and I want to interchange Z with alpha. Okay, so let me try to understand the logic. So I know that this inequality is valid for all choices A, B, and Z in X. Now I am assuming that alpha and beta are in X, so I can use this inequality in a way that I choose alpha to be beta, B to be beta, Z to be alpha. Yes, that is possible. Okay, and then let me rewrite that inequality. So the left hand side becomes D. Instead of A, I put beta. Instead of B, I put beta. Less than or equal to D. Instead of Z, I put alpha. Instead of A, I put beta. And then plus D. Instead of Z, I put alpha, and instead of B, I put beta. So I want you to really understand what is going on. So this inequality is valid for all choices of A, B, and Z in X. So because it holds for all choices of elements A, B, and Z in X, that is also valid if I choose A to be beta, B to be beta, and Z to be alpha. So then if I rewrite that inequality for these choices, I will have this inequality. But I know that if the elements A and B are the same, D of A and B is 0. So I can immediately see that this is 0. And I see that these two are the same number. So when they are added, it becomes 2 times the one of them. Yeah, so this becomes the left hand side is 0, less than or equal to 2 times D alpha and beta. And now if I divide everything by 2, so D alpha beta is greater than or equal to 0. So I was able to show that for any choice of alpha and beta in X, the distance D of alpha and beta is greater than or equal to 0. So that's one of the conditions. Of course, the second condition for being a metric is exactly this one. So this is automatically satisfied based on my assumption. The third thing that I want to do is to show that this D is a symmetric function. So let me go to the next page. Okay, so what we do, again, I would say that let alpha and beta be in X. Okay, we show that D alpha and beta is equal to D beta and alpha, because I need to show that this D is indeed a symmetric function. In order to do this, I will use this inequality by two different replacements. So how? The first one, because this is valid for all choices A, B, and Z in X, it is also valid if I do this interchange. A with beta, B with alpha, and Z with alpha. Yes, so if I do that and rewrite this inequality for these choices, I will have D, instead of A I put beta, instead of B I put alpha, less than or equal to D, instead of Z I put alpha, instead of A I put beta, plus D, instead of Z I put alpha, and instead of B I put alpha. Okay, so what is the consequence of that? So we know that this is indeed equal to 0 based on the first condition. So I realize that d of beta alpha is at most equal to d alpha and beta. Okay? So that is concluded from these two properties. Now I choose another set of replacements. So I choose another set of replacements. I replace A with alpha, B with beta, and Z with beta again. And if I rewrite this inequality, what do you get? Is that D, instead of A, I put alpha, instead of B, I put beta, is less than or equal to D, instead of Z beta, instead of A alpha, plus D instead of Z beta, and instead of B beta again. But again, you see that because of the first property, this is 0, and then what can I conclude is that D alpha beta is less than or equal to D beta and alpha. Okay? So this is number 1, and this is number 2. So from number 1 and 2, I can conclude that, of course, these two numbers are equal, yes? So from number 1 and 2, I conclude that D alpha and beta is equal to D beta and alpha, because the only possibility that these two inequalities are met simultaneously is that case. So this means that I was able to show that for any choices of alpha and beta in X, D alpha and beta is equal to D beta and alpha. So it means that the function is also symmetric. The last thing we need to show is to show that for any choices alpha, beta, and gamma in X, so I would say let alpha, beta, and gamma be in X, we show that the triangle inequality holds. In other words, we need to show that D alpha and gamma is less than or equal to D alpha and beta plus D beta and gamma, if I can show that. Of course, now it is very clear what to do. Again, I do substitutions here in a way that I am able to show this inequality that I need to show. And for example, here I can do this. I can say that, okay, I change this A to alpha, and then B to gamma, and finally so B to gamma, and then I need to choose Z to beta. Okay, so if I do these substitutions, the left hand side becomes D, instead of A I put alpha, instead of B I put gamma, is less than or equal to D. Z is beta, and then A is alpha, plus D, Z is beta, B is gamma. So I get this. Okay, but we just showed that this D is symmetric, so there is no difference between D beta and alpha and D alpha and beta. So what can I do? I can continue. I copy and paste the left side is less than or equal. Instead of D of beta and alpha, I put D alpha and beta, and then plus I copy and paste the last term. And that is exactly the inequality that I wanted to show. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.